Hi, everyone. Thank you for having me here. My name is Gurdeep Gill. I am a software engineering technical leader at Cisco Systems. I do help deploy and validate security systems, and my main expertise are in encryption and decryption services of security protocols. And today we are going to talk about how to scale the automation for these security protocols. So before we discuss the problem, um, let's try to understand what are the security protocols. So anybody goes on any site, let's say you go open a google.com. Before that page opens up, there are many things happens in the background. Um, there is different layers, for example TCP layer, TLS layer, QUIC layer. There is a negotiation happening between client and server. The request that you sent from your laptop, it goes to the server, and then you get to see this page loaded on your screen. But then negotiation, there are many things happen there. For example, what kind of protocol was negotiated, and then what kind of cipher was negotiated between client and server, key shares, different algorithms. Was it a PQC? Was it a QUIC? So all those negotiations in the background requires a lot of testing, lots of different combinations, and that's what we are going to talk about today. How to scale, how to test all that large number of combination that we have that keeps our information secured, how to test that in the real time. And when we talk about these variations, for example, TLS protocols, there is like 1.2, 1.3, and now we have a QUIC. And if we go for the older version, we had a legacy protocols like 1.1, 1.0, and SSL-v3. And there are some very old systems that still have these legacy protocols, and how our middle boxes are when traffic goes from client to server, how that behaves. So we have to consider all these different combination. And then when we do the handshake between client and server, then what kind of different key shares we can do. TS 1.2 have their option, 1.3 have its own, QUIC has its own variation. And nowadays, if you have noticed, the Chrome browser use a PQC algorithm, the new algorithm that they have developed to keep our protocol, our traffic safe from the quantum computers. So we're going to talk about all those, and when we combine all those together, and then the combination of that becomes thousands of tests. And how are we going to scale our automation to create those thousands of tests so that we have that testing done before the release? So the testing framework that I'm going to talk about, that's data-driven. All the resources will define as data, and it will be that's the most important part, the architecture, how we define the architecture, and we're going to have it defined as a layered architecture, one thing at a time and independently. Then automated execution. Let's say we have all the automation, but how are we going to execute it? So we need to have that execute for us. We need to have some dashboard or some kind of structure in place which execute as you want it to be executed. Now, we have all automated it, but how do we validate it, right? We can automate whatever we want to, but if you don't know when fail, why fail, right? So we need to do that validation at scale as well. Now, the maintainable. I have seen the automation framework. There are like very lengthy, very complicated, but when you have to add a new automation, it takes days to add new test scenarios in there. So that's another thing we're going to take a look how we can keep it simple so that it's easy to add as well as easy to debug your automation framework. So the key benefits, again, manual testing in today's environment, it's very lengthy and it's not practical and it's boring as well, right? So how we can move to the automation to keep our testing within hours instead of taking it days or months and where we cannot even repeat it. coverage. With this automation framework, we can have the combination, whatever we want to test. We don't have to skip on, like, this is the only scenario we can test because of the time limitation. Repeatability, whatever we ran last release, we can run it again to make sure we have not caused any regression in the new changes. And also easy to add and easy to debug. And again, the topology here I'm going to talk about, where you have a client and server, and in the middle you have, it can be a firewall, it can be any load processor where the traffic goes through before it gets to the server. So client, server, and in the middle box. So now the design. The approach that we have here is, it's a 5-layer design. It had 5 layers, and the first one is the data. Now, when we do for the TLS protocols or any security protocols, there are so many different protocols out there. There can be TLS, there can be QUIC, there can be FTPS, there can be, HTTP2, HTTP3, there's so many different combinations. All of that data, all of those resources we're going to define here at one place and at the data layer. It can be all the ciphers, your different algorithms, curves, certificates, your PKI infrastructure, or what type of clients you want to use. Your client can be a browser, your client can be Linux, or any other endpoint. And the clients can be like curl, OpenSSL, wget, or the server, different types of server, like Apache or any type, whatever you require to simulate the traffic. So all that will be defined in an independent layer, the data layer. And then the second one is a config. This is where you define your test metrics. Whatever we are going to simulate may not be true for QUIC protocol or may not be true for FTPS. So this is where we're going to define the test metrics for 1.2, what kind of ciphers it needs to be tested, what kind of combination of key share, or what kind of certificate or the PKI algorithm is supported. That will go under the config layers. And also the rules. Whatever the middle box you have, it has its own variation, how it's going to process the traffic, what kind of rules you need to define. Is it going to allow, is it going to block, or how it's going to act on particular traffic when you send. So all those rules will go under on the second layer, which is a config layer. Third one is helpers. This is a layer which will take what we define in data and the config, and then we will generate the tests out of it. We will, in the second, as the config is provided, what is valid for which combination. Then the helpers, where we will generate that, put it in the loop, or do the generators, which will give, let's say, if you want to run 1.2, what kind of test combination it will run, how many tests you can run to have all that extensive coverage of your test areas. And then the third one is a utils one. That's the main lengthy part of this framework, where you're going to actually create the execution engine for every step that you're going to do. Any settings you require on your firewall, any settings you require on your client or on the server, or any common setups, all that will be defined here. And then what are the expectations? How do you know if this is pass or if this is fail? How do you know if QUIC runs through your load balancer, how should it act? How should it react to that traffic? What's the behavior? How do you validate that it actually went through successfully or did actually inspect it? So how do you define all those pass or fail for each scenario will be defined in this layer, in this utils. And then the execution engine, how do you simulate the traffic? How do you simulate QUIC traffic, or particular client type curl traffic or OpenSSL? How do you simulate, let's say you want to do resumption? How do you do that? So those all will be defined here, the execution engine. They can be different execution engine for different types of traffic that you want. And then the last one here is a test script. The test script is which will bring everything together. Test script will give you the capability, what kind of suite you want to run. Do you want to run just one, two? Do you want to run just QUIC only? Or do you want to run particular key share or particular ciphers? This will give you the capability instead of running everything, but as you want, as you need, based on the requirement. or based on the test needs at that time. So the first one, data layer. Here is just an example where you define what kind of supported parameters you have. You can define what is not supported. And then you can define different types of the PKI, RSA, ECDSA. There is a new PQC, PKI is coming. You can add that. And then the endpoints, what kind of endpoints support it needs. Does it need the HTTP server, IMAP server, email server? Anything that will be defined, that data will be defined in this layer. On the layer 2, that's where you will actually define the test metrics. The test metrics, for example, as I mentioned earlier, you can define, let's say you want to do HTTP3. Now, HTTP3 only belongs to QUIC traffic. This layer will tell you that how it will integrate HTTPS to 1213 and all that. How will it keep it separate from FTPS or any email protocol or HTTP3? So here we will be able to differentiate between the different traffic and what are the expectations from that traffic. If you have firewall or load balancer in between, if it's a clean traffic, what is expectation for that traffic? What is expectation if you run resumption? Did it actually resume? So all that validation criteria are the expectations you define here. And also the rules. What kind of variation of the rules you want to test through your firewall or the load balancer, that will go in this layer. That's where you will define that. Now, the third one, the helpers. This is where you will get the test generator. This will get where you get how many numbers of the test combination is going to generate. So you will you will use the layer 1 and layer 2 and then create a combination and place a logic that for TLS1.2, if I'm asking for this cipher, then tell me how many combination of the tests you can actually generate. And it will give you the test metrics for that. The fourth one, this is where you will execute whatever setting you need for on your load balancer. Let's say you need to deploy some kind of access rules or block rules. You will define that in the deployment manager, one of the execution engine as an example. And then you need traffic generator. So let's take a look at the whole thing, right? So you have everything, all the environment is set up. That will go under the common setup, and then you can do the other common setup based on particular tests, where it go and use the deployment execution engine and deploy particular access rules on your firewall. And then after that, your setup is ready. And then you can go and use execution engine, which will simulate the traffic. For simulating a traffic, it will go set up your server and then simulate the traffic from the client and then go run the traffic, and it will get exercised through the deployment the policy that you have deployment on your firewall. And then once this all is done, then through each step you will have a validator. You validate when you did execute the deployment engine, did it actually deploy the policy? If it failed, what failed? So that validation will go through that pass and fail criteria. And then same, it goes through the other. Did server actually running at particular port, or is server actually running FTPS, or what kind of server you started, did actually it started? So you have the validation for each and every step there. And then you generate the traffic, curl traffic. Did it actually generate the traffic? Did your firewall actually saw the traffic? And when it saw it, how it processes, how it acts on it? You validate that on the client side, then you validate on the firewall side, and then you have some kind of logging that you can validate. This is the execution engine, the heavy one, because that's where you have all the execution as well as the validation. But if something fails, then you can here do another layer where you can collect all the logs and then use that for debugging. If something fails, what to do next? That's where you can have all those sub layers added for your debugging purposes. The layer 5 this is where you bring everything together. You have a common setup. It will know how to bring all the layers together once you run. So this will be the main script where where you will run this to run everything in from one layer to five layer, or whichever order your tests are done. So you will have a common setup, pre-requirements, then you deploy, and then you execute the traffic part, validate it, and that's where you will actually define what kind of filter you need. You may not want to run all those 3,000 or 1,300 test cases. You just want to filter based on what kind of testing requirement. It may be based on what kind of changes went in. You may just want to prioritize those, and you can define that here in this layer. So again, bringing these all layers together, you will define data, whatever you want to test, and then you will define what kind of config is for which category, and then you will have a test matrix, and then you will have execute all of them. And how you execute, you will have your own at the end the runner, which will bring everything together. The examples to add a new test, let's say you want to add just one new cipher. You just add it in your data. You don't need to, you probably don't need to add in the config if the ciphers are already part of the data layer. Everything is already done and nothing else is needed. So you can run all those hundreds tests with a new cipher, with other key share, all those combinations. And then let's say you want to add a new test scenario. You want to test the TLS13 with 0 RTT. It doesn't require anything in the data, but it requires a config. Now you're defining what is 0 RTT. It belongs to 1.3, and what are the scenarios for that? And then you will define the execution engine for that, how you execute, how you simulate the 0 RTT traffic. That will go under your utils layer, and that's where you will actually validate. And that's all you have to do. You just find which layer requires need to be updated for this particular scenario, and then you will just update that, and the rest of it will take place itself. The test runner, this is just the example how you can select the different filters, and instead of running everything, you can select based on your need. You can even create a test suites, even running them in a parallel. You just want to run 1.2 or 1.3, or just want to run QUIC, or want to run particular one, want to skip the other one. So you can select based on that. You can also select based on the data file. You can have a data tags for QUIC or 1.3. You want to run all those, but maybe in parallel, then you can define based on your runner to select that filter. You can also have an option to rerun your failed test cases. This is in the automation, this always happens, right? There is always some kind of failures. How to trigger just those failed test cases instead of just running everything. Now we are automating so many test cases. Your test metrics will create thousands of them, but running them one by one can be really time consuming. So you can have different workers in place so that all goes in parallel to complete in within the less time as compared to running them one by one. Now we talk about adding an automation, but what we have learned from when we add all the automation, it can run all of them, right? What happens when something fails? That's where we consume a lot of time debugging, looking at the logs, and doing all those, digging into those logs. So many clicks goes into until we find out what really happens to automation, like where it fails. So another part of this layer is where the validation is very important. Validation needs to be added at each layer. Every step that we do, it should have some pass or fail criteria, and should have a log in a way that you can consume easily, so that when something fails at any step, you know why it failed, instead of going and digging into different logs and trying to find the answers. So again, overall the configuration is you define the metrics, you generate the test, and then it will execute for you. This is just an example at high level how, let's say you have these test metrics defined. And then out of this test matrix, your framework will actually generate the test cases. And the test cases name can be helpful defining, let's say if it failed, then it name itself can tell you which particular test failed. Let's say the third one that tell you, oh, this is HGB2 and it's with 1.3, it's using this particular cipher, it's using ECDS API, it's using this particular key share, and it's just a basic test, right? And you can probably separate basic all differently, resumption separately, and then inspection separately. Now, if the basic tests are failing, you don't need to go debug the inspection. Basic itself failing, inspection most likely is going to fail. So naming the test in a way so that it's help you to look at from a high level and kind of consume quickly what we are talking about here, what we are seeing, looking when we're seeing at those results, what failure are we looking at it. And also you can create a report in a way so that it's easily tell you pass or fail, or have an option where you can go if you want to see in a more detailed what kind of particular settings this test has. For example, what kind of policy it use, right? So you can probably add that in your test name itself as well. So we can scale the test to the thousands of test cases, but again, the parallelization is important. How do we divide into multiple workers so that all of them run quickly and fast, and so that we have results as soon as possible, and we can run maximize the test execution um, with the parallel execution method. We can also do distribute testing. We can use multiple different resources. We can do divide the work evenly on a different node. There's so many different methods, and again, it can be different for different environment. But this is something can be considered when we have thousands of tests to run. Again, other thing, smart queuing. That's where you want to test something, but you know which area it went into. You can prioritize based on that. You can prioritize based on whatever that is fast and whatever is slow. Put it that at the end. Incremental testing, the same point, based on changes, you can just test only that area. So let's say you have all the framework in place. Now you don't want to do anything. You want to set it up for itself. Any changes comes in, any changes even go out. You can set up some smoke test before changes goes out, and then you can identify the highest priority or the highest value out of those thousands of tests and set up them as a sanity before your changes checked in. And after changes checked in, you can do for each build which will run and make sure if there is any regression, then it can catch it immediately. Same way you can do nightly runs, you can do weekly runs, you can do daily runs, or you can do monthly runs based on a different filters or criteria you want to. Um, we can all run anything in this framework, right? But if the dashboard does not give you or tell you what passed, what failed last week, I want to look at these results from the last week report or build, then it's again so many clicks to find out that answer. So it's good to actually invest in the dashboard or the portals where these tests go log, and where your team can go see the results, what pass and what fail, and what is the quality of your runs from yesterday as compared to the day before yesterday or as compared to month. So it's good to invest in some good portals or the reporting dashboards. um, we can create our automation the way we want to, but the mindset, if we go with keep it simple and easy and independent in the different layers, it will make everybody's, whoever is joining new or whoever is already working, adding a test case is much easier. So if your framework is easy to adapt, then adding and debugging will be much easier. So keep that in mind, that you want to keep everything simple. You don't need to make it complicated, and that way it will save everybody's time to add and debug the test cases. Design principles and implementation tips. Go ahead. Yes, you can tag them as you want to. Yeah. Um, as we talk about these 5 different layers, it's very important that you keep these layers independent and unique from each other, so that if there is a newcomers coming, or if there is something failure happens, or we break something, then it will tell you, it should be able to tell you that where the breakage happened, or where which layer you have to add. So keep the effort that work in the starting, so that this layer is independent from the other layer and it's unique but still connected, um, so that it's easy for, and it's independent, and each of the layer has its own responsibility. And then the data driven, especially with the example, the security protocol, there's so many variations. You don't want to hard code these things in all of the different scripts. You want to keep that at one place. If something changes, then you just go and change at one place instead of changing a number of places. And also, if something new comes, for example, now the new PQC key shares are coming. They're hybrid, and then the new, and then they're a classical. If you have a framework where the data is defined in one layer, then all you have to do is just define those key shares in that data config, and that's all you have to do. Maybe minor changes where you want to, if the validation is different, you just have to update that. um, don't repeat yourself, same. Don't hard code, or keep it at one place, so that you don't have to change it in multiple places. Don't get overwhelmed with the mind that, oh, there's so many different combination, I have to test and automate all of them. Start small and slowly increment. um, Another important thing, automation or testing always keep at the last. Most of the dev work goes into, where the most of the majority of the time is spent. But automation is also important. That's what tells you the quality of that feature or that product. So the testing of the automation itself is important as well. So as you are developing the automation framework, make sure the testing of itself is also developed, and that can be done with the unit or the different frameworks there. um, Another thing, I know, I mean, there's so many other priorities comes in, and when we document, we kind of, put it on the side and not do anything, not do much about it. But document wherever it's possible. It's good for the newcomers. Is sometimes things change, and then when years to come, you can go back and look at those documentation, and that can help. um Already mentioned hard-coded test data. That's not really a good approach. Make sure it's only under one config or at one place, not hard-coded on your scripts. Keep each layers independent. Manual validation needs to be part of the automation itself. It just doesn't should not only tell you, oh, it passed and failed. It should tell you why it passed, so that you don't have to rerun manually or debug it or do all those extra works. Automation should be very to reduce your work, not create more work for you. um, any tests which are flaky, so again, it depends on the framework, how each layer has been defined, what kind of the clear cut pass and the fail criteria for each thing that we do in our automation framework. That's where how you determine what's a pass, fail, and what does it tell you. Performance optimization, again, thousands of test cases, running them and just waiting for them. Do the parallel execution. Find out where you can make it faster. What are the things where you can optimize it? For example, let's say you have a curl or OpenSSL where you have to build those before the setup. Can you build them in advance? Have them already available so that they are copied to wherever you want to run them. You make use of the instances which are created, reuse them as you want to. um, this is again go back to the metrics. How do we know, how do we measure how we measure the quality, how we measure the quality of our automation framework, how we measure the quality of the product that we are testing. So the dashboard, how the logs are done in a way so that's easy to consume. So that's where also somewhat work is needed, even though all the automation framework is completed. But if that data is not consumed easily and quickly, then again it creates some more work for you. So spend some time, invest in the dashboard where it presented your data in a way so that anybody can look at it and tell you what happens last month to this build, and what fails and why fails, when it recover, why it recover, what happens in those days in the between. So the key takeaway is the architecture. I have seen the automations which are very, very complicated. We ourselves did it. We went with a very complicated approach, but then we rework it. Then we separate all the layers separately. And then today, the automation framework that we have, it's very simple. Anybody can get ramp up in within a days and can actually add the automation easily. So put the initial work in those layers to keep it independent and easy to debug. um, Automate anything that you are doing, it is automatable. The reason we don't automate is because we think, oh, it's going to take a lot of work. But if your framework is in place, then there is a possibility, there is chances that you can spend that time and that repeatable work can be automated. um, Again, start small, start with one area and then enhance it further. Again, your framework will, the way it's defined, it will tell you how easy it is to add and debug. So keep the simplicity in your mind. um, Validation, every layer of the automation is important, but I think the validation is the most important. We can execute, but if we cannot validate at and tell us what fail and why fail, then it again creates more work for us. um, Invest in different toolings from the starting to the end. Figure out what kind of tools you require and what kind of architecture you have and what kind of investment that you, which area is the more valuable and where you should invest. And then for the future you will have, you can kind of slowly invest in different area, but start the one which has the highest value. So let's say you want to create a new framework for your team, where do you start? First of all, you need to know the architecture. What is your topology, what you want to test, what is end to end that looks like. Collect those requirements. Once you have the requirements, then to try to put them into different layers. Can you separate them uniquely, differently, independently? Define those, and then start with the small. What are the different layers, small things in these layers you can generate? So start with that, and then build upon the other layers, and see it for small set of the test cases if end to end it's working. Once it's working, then you start adding a more to it. um, when when you're adding automation, performance, when you're starting from the small, performance may not matter, but when these tests adds up to 1,000, then the performance matters. So keep those things in there from the starting, and optimize as you go along. Keep the performance um, in your criteria, and also integrate it to the CI/CD. So once it's built, it will go and run it for you in the CI/CD. All you have to do is just look at your dashboard and see what's your today's results from those runs. I think that's it. But you may all wonder, I didn't mention AI at all, right? I know AI is there. I know everybody's using it, but I think we should start our own first, because we should define our requirements first and start small. And every step, that's where you make use of AI as assistant. That how can I optimize this particular layer? How can you help me there? If we give everything this to AI probably gonna make it complicated. Then you will maybe wondering in a month, oh, where I go and what do I do? So yes, we should use AI, but do your set up your foundation first and then make use of AI as you want to. And that's it. And you can reach out to me from my portfolio. And thank you, everyone. And thank you, Kyle, for.
So does anybody have any questions they'd like to ask her right now in the room? Raise your hand and I'll scurry as best I can. Anybody want to come off mute and ask any questions? Say, oh, or is that a stretch or a question?
I'll go because I feel like the idiot asking this question. So did you end up implementing your own full testing all the way down framework, or are you just applying an architecture on top of common testing tools?
We actually build up from the ground up everything.
Okay, can you help me understand why that was integral to your process? Why not borrow from one of the common test frameworks that define things like a tagging structure and some sort of organizational? Why was it important for your? Was it just for your use case, or is this what you're saying we should do?
Yeah, it's a use
otherwise.
Yes, it's mainly use case and then the particular requirement for a particular scenario, when especially the corner cases. So borrowing different tools from somewhere here, it itself was a lot of work. So we set up the framework itself. We're bringing a different tools was easy.
Okay. I guess I'm going to be a little puzzled by that one, but okay.
Anyone else? If not, we can say thank you, Gurdeep, for doing this, Ms. Gill.
Thank you, everyone.
And that will conclude our February meeting of the OWASP Boston chapter. And the gentleman who asked the question was actually going to be our speaker next month. So everyone will be our speaker. So please come and listen to him about DevOps and AI automation or something like that. And just kidding.
Share some love. The intention is to share some love from the zero trust mindset on your DevOps ecosystem. Particularly, I'm going to stick with one surface, our endpoints, our developer endpoint surface. And what does that look like with the changes that AI has brought into the landscape? And what does it mean to kind of safely work in this environment? So I know some of us probably all have figured out some pieces, but I'm rolling this up into a few core tenets to think about, making sure you approach each time you lay out a new developer ecosystem to give the developers freedom, but safety at the same time.
So once again, that is the conclude the meeting. Thank you all very much for attending and see you all maybe at the happy hour. Have a great day.
Thank you.